I work with ecological models. These are computer-based models. There's a whole bunch of different kinds of them, but the kind that I work with is called individual-based gap models. They're a really well-established class of models, and the thing that's unique about them is that they track the processes, the life history processes of each individual tree in the forest. So, and individuals, and this is all with math. This is all computers and math based. So there's all these different equations out there that kind of correspond to how individual trees react, how they react to shading, competition, resource limitations, things like that, how they grow in the forest, what their sizes are. And as a NASA scientist, we actually measure some of those variables from space. So we sort of look at how we can look at these satellites with these models to answer questions about our planet. So this is just an example of the current missions that NASA has of satellites up around the planet up through, I guess, the year 2023. So some of these have already been launched. Most of them have already been launched, but a couple of them are on the horizon that will be launched pretty soon. And so all of these satellites, we've got airborne sensors, we've got terrestrial lidar scanners, we've got radar. Lidar is basically laser scanning. And we have all of these different missions in space where we're orbiting the planet and collecting data. But it's not that easy. We don't just collect data and then all of a sudden we have the picture like we might see in a book. We have to do tons of processing, tons of math. There's a lot of engineering that's involved in it before we can get the kinds of products that even a person like me as a research scientist might use. So this is just a quick example of some of the information and some of the process that's involved in getting a raw satellite collection all the way to a map. So it's an example of how scientists might process these data sets. So this is actually a tool called JEDI, which it stands for the Global Ecosystem Dynamics Investigation. And it's a high resolution laser scanner, basically, that was sent up to the International Space Station a couple of years ago. And right now it's up there and it's measuring really, really precise measurements of forest canopy height and canopy vertical structure and also surface elevation. So we can use those three different variables to subtract how much, and basically then apply math equations to then understand, what our the biomass is of our planet's forests, as well as, and we can use that to kind of translate that into carbon. So how much carbon are our forests storing? How much are they emitting every year? And what does that mean for climate change in the future? So I was just going to say the typical process stream whereby we end up with the decision makers in the room. That's not a very good. It's kind of a funny picture, but we do actually have a lot of meetings where we present a lot of these data sets to each other, and the next step usually is that our headquarters, our NASA headquarters, take this kind of information and the reports that we make to Congress to try to educate the legislative members of Congress towards the future in terms of how we need to regulate or deregulate how we're emitting carbon. So it usually looks like the satellite is grabbing data, and we use all of this different math. We have to go to the field to measure the forest to be able to then directly connect it with what we measure from space. And then we use that to, if this is the path of the satellite measuring these dots, we use the math from there to basically be able to extrapolate it across the entire, over space and through time, so across the entire landscape, and then also related to time series. And from there, we can then build these maps that we then use with assessment and monitoring and sort of decision-making topics. So my research basically deals with, like I said before, these individual-based gap models and how we can use them to enhance and streamline the process of getting these satellite image data from space into the meetings that are most important amongst our policymakers. So there's a couple of different ways. So first is we can use forest models to improve how we calibrate our remote sensing, remotely sensed data sets from space. We can also do it by swapping space for time, so forest models can improve how we make the maps. And then we also can use these models, and this is what we're doing right now, actually, in a project that I'm working on. We can use them once we have a working model. We can use them to put in climate change scenarios to kind of project future what will happen, given the different scenarios that the Intergovernmental Panel for Climate Change has put out, the IPCC. So we can use them overall also to kind of understand carbon dynamics and their effects on land use change. So these are just a couple of projects that I'm working on to kind of give you an idea, but all of these are sort of, encapsulate what I've just been talking about with respect to modeling and remote sensing. Some of them deal with more, one more than the other. This one here is kind of another baby of mine that is kind of back to Madagascar, which is where I love, but basically using modeling and these mapping methods to actually look at, to see if we can detect patterns in deforestation, if we can link them to economic indicators like the price of rice, for instance, because rice is the staple in Madagascar. So a whole bunch of different things that we can use.